All right, in this video, we're going to look at proportional reasoning. It says the Heart Health Association is holding a 5K fun run walk, and an artist has donated his time to enlarge the logo for the advertising banners and the t-shirts that will be given to each runner. Many professionals, such as graphic artists, architects, and engineers, work with objects that are enlarged or shrunk. In this lesson, you will explore the mathematics behind these changes in size. Since the artist wants to set up a spreadsheet to calculate the dimensions of the graphics for the t-shirt and banner so that she can reuse it for future projects. She's not sure how to write the formulas correctly and tries different options. Which of these three options creates a proportional relationship? And they give us a hint. It says, if a relationship is proportional, the image is not distorted. So our original object here has a height of 1.67 inches and a width of 2.49. This is the original dimensions. It's the same on all three columns. But notice in column B, they keep the height the same, 1.67, 1.67. They only make it wider. That's going to change the shape. It's not going to be proportional. To be proportional, that ratio of width or height to width, width to length, however you want to do it, we'll do height to width, should stay the same. That way we don't get a distorted shape. So you can see that with the original, that ratio is 1.67 to 2.49. If we put that in a calculator, 1.67 divided by 2.49, we get a ratio of 0.6707. You could go farther if you wanted to, but that gives us what our ratio should look like. Okay, let's check out this middle row. What happens? We know that 1.67 to 2.49 gives us this 0.6707. What happens if we use this row? What about 6.68? That's the height compared to 8.72. That does not come out. That comes out to a ratio of 0.7661. Or if we do this one, we get 25.05 to 32.37. Each one of these times we're just looking at height divided by width. And that comes out to be 0.7739. These are similar, but they are not 0.6707. So I don't think this is working either. Let's try this last one. I do the ratio of 0.835 to 12.45. I get 0.6707. Oh, that's what I'm looking for. That's the original. So this is the t-shirt. Let's check out the banner. If we do, I'm running out of room. I'm just scribbling here. 23.38 compared to 34.86. I get that same 0.6707 ratio. So this one works. All of these, if you look at the ratio of the height to the width, they're the same. They're proportional. I think this must have just been more room for us to do our work. But yes, when things are proportional, that height to width is a constant. They all equal the same number. So if you look at this last column, these last two columns, 1.67 over 2.49 is equal to 8.35 over 12.45, which is equal to 23.38 over 34.86. We just have a constant height to width. It says use the correct option from question 1. Write the spreadsheet formulas that are used to calculate the width for each version, t-shirt and banner. Use the column and row labels to show for this. We are not going to worry about all of this. I think this is not necessary for you to do the homework. It says you are a graphic artist hired to make a billboard for college. The original logo is 2¼ inches wide by 3 3/8 in height. You need to enlarge it to a height of 6 feet. How wide will the enlarged version be? So we're going to do that same reasoning that we want a constant height to width ratio. The original logo is 2¼ inches wide and 3 3/8 inches high. So we have 3 3/8, and it's 2¼ And the new version is going to have a height of 6 feet and an unknown width. Notice these are both in inches and this one's in feet, and that's okay. That just means this one will come out in feet. The units are going to be consistent. Now, we have this issue of working with fractions or working with decimals. Let's go ahead and change things to decimals. I think that will be easier for most people. 3 3/8, well, 3 divided by 8 is 0.375. And 2¼ is 2.25 equals 6 divided by x. Now remember, we talked about before, how do we solve proportions? We're going to change our ink here so I can show you what I'm going to circle. I'm going to multiply these two numbers together. 3.375 times x, and I'm going to multiply these two numbers together. 2.25 times 6. Okay, I can go ahead and do 2.25 times 6. This side is 13.5. And this is 3.375 times x. I need to finish, so I divide by 3.375. And that just gives me 1x equals 4. So the answer is it needs to be 4 feet wide. If we look at that ratio, 3.375 to 2.25 is 1.5. If we look at 6 feet to 4 feet, we see that that's also 1.5. So that's our answer for the enlarged version. It says, in the previous activity, you began with the college logo that was 2.25 inches wide by 3.375 long and enlarged it to the new length that was 6 feet. You may have set up a proportion such as this, and that's exactly what ours looked like. I think we may have been the other way, I can't remember. Is the proportion below also a correct representation? If so, how would you solve it? Well, let's see. We know how to solve this. Looks slightly different. We do 2.25 times 6. That's 13.5 equals 3.375x. And then we divide 13.5 divided by 3.375. And we got 4 feet. So we just reworked it. Let's look what happens if we solve this one. Notice we get 6 times 2.25, that's 13.5, and we get we get the same thing. So this tells me I think we're doing it right. All right, and the answer obviously is we get the same exact solution. So how can we take a proportion and rearrange it? I'm going to kind of erase all of this, and I want to just show you all the different ways you could take this and rearrange it. Whoops. Okay. It's one of the ways you can rearrange it is instead of going 2.25 over 3.375, you can go the other way. So I'm going to think in terms of, whoops. Let's go this way. Let's put 3.375 on top, 2.25 on the bottom. And if we go that way here, then we're going to go that way here. And we'll put 6 on top and X on the bottom. That, of course, gives us what they had below. So one way you can get an equivalent is simply to flip them both. It's not the only equivalent. I could also go sideways. I could say X over 2.25 equals 6 over 3.375. Notice if you cross multiply, you're going to get 6 times 2.25 and 3.3. So you'll get the same thing when you cross multiply. So you've got to check that that's equivalent. We could go this way. That would be 2.25 over x and 3.375 over 6. Notice when I cross multiply, I still get the exact same thing. I get that 3.375 times x is going to equal 13.5. So when you have these proportions, you can go a lot of directions. Like say, instead of going from 2.25 over, we went 3.3, we went this way, that way, this way. But they all give us equivalent proportions. All right, to solve each equation round to the nearest 10, we're going to use our cross multiplying technique. 0.2x equals 3 times 12.7 or 12.7 times 3. So 0.2x equals 3 times 12.7. That is 38.1. And then we divide by 0.2 to get x by itself. That's going to give me x equals 190.5. do the next one. We're going to cross multiply. I'm going to do the x. Doesn't matter which cross I do first. I just like to do the x first. So 4,200 times x equals 8,500 times 5. Well, that one's easy. 8,500 times 5 is 42,500. This is 4,200x. So now we divide by 4,200. And when I get x equals, and I get 10.1. They told me to round to the nearest tenth. My calculator actually had 10.119. But to the nearest tenth, I'm just going to get 10.1. It says many small engines for saws, motorcycles, and utility tractors require a mixture of oil and gas. If an engine requires 20 ounces of oil for 5 gallons of gas, how much oil would be needed for 8 gallons? So we like to label things. If we say 20 ounces oil and 5 gallons gas, we not only know what units we're using, but what's going on. How much oil for 8 gallons? X ounces of oil for 8 gallons gas. Now you don't have to really worry about the labels. We can cross multiply. When I cross multiply here, I'm going to have 5 times x, and that's going to equal 20 times 8. So 5x equals 160. When I divide that by 5, I get 32. So divide by 5, x equals 32. What is x? 32 ounces of oil. All right, that takes care of the proportion, but before we continue, I want to kind of go back and do one other type of problem I saw on the homework, and that was problems that involved more than the ratio of just 2 things. So I'll make up a few problems here. I want to help you be successful. Suppose that, and this doesn't have anything to do with this, the local animal shelter says the ratio of cats to dogs to exotic animals. Exotic. I think I misspelled exotic with an extra C there. Let's fix that. And by exotic, most veterinarians really just mean things like people that have birds or snakes or something, and iguanas, something besides cats and dogs is all I really mean here. So the ratio of cats to dogs to exotic animals is, I'm going to say 6 to 4 to 1. That means for every 6 cats, we would expect to see 4 dogs and 1 exotic. We'll just label that with an X for exotic. Another interesting thing you may want to see when you see these kind of 3-part and 4-part ratios, or even 2-part, is the total. 6, 4, 1, that's 11 total. Let's ask some questions. If there are 24 dogs, how many cats? Well, that's pretty easy. Well, there's 6 cats for every 4 dogs. So if I have 24 dogs, I would expect there to be X cats. And I'm going to put EX for exotic. I don't want you to mix that X up. You could use a different variable, but you get the ratio of cats to dogs is 6 to 4. 6 to 4 cats to dog. X cats, 24 dogs. I cross multiply to solve that. I get 4X. Make sure you know what I'm multiplying. When I cross multiply, I'm multiplying 4 times X. Oh, I didn't change colors. I'm multiplying 24 times 6. Well, 24 times 6 is 144. This is 4X. If I divide by 4, I would expect 36 cats. Notice you see that common ratio. 24 dogs is 6 times bigger than 4 dogs, so I'm not surprised that cats-wise there's 6 cats. How many exotic animals would I expect if there's 24 dogs? Well, there's 4 dogs for every 1 exotic animal. If there's 24 dogs, I would expect how many exotic animals? Again, I cross multiply. 4X equals 24. I would expect to have 6 exotic animals. 6 oddballs. Birds, snakes. Snakes are the worst. Okay, let's do one more. Let's not change the setup, but if there are 55 animals in the shelter, how many are dogs? Well, 55 is the total. We know there's 4 dogs if there's 11 out of every 11 animals, right? 4 dogs out of 11 animals. So how many dogs out of 55 animals? Again, we cross multiply. 11x. 4 times 55 is 220. Divide by 11, and we get x equals 20. So if there's 55 animals in the shelter, we would expect 20 of them to be dogs. How many would we expect to be cats? Well, if I wanted to know how many cats, I would say, well, 6 out of every 11 animals is a cat. So if there's a total of 55 animals, how many do I think will be cats? 11x. 55 times 6 is 330. So when I divide, I see that I would expect there to be 30 cats. The rest is easy. If there's 20 dogs and 30 cats, there must be a total of 5 exotic animals for a total of 55. All right, that finishes up proportions. The next part of this lesson is about solving equations. This is our basic Algebra 1. Keep both sides of the equation balanced. We do the exact same thing to both sides so we can solve for the thing we don't know. To solving equations such as blood alcohol content and proportional equations for resizing graphics is an important skill. Mathematical models are often constructed to represent real-life situations. Being able to use these equations fully includes being able to solve for unknown variables in the equation. This lesson presents 2 scenarios for you to practice and enhance your equation solving skills. With each problem, check that the answer is reasonable given the context and that you have included the correct units with your solution. It says Paula has 2 options for going to school. She can carpool with a friend or take the bus. Her friend estimates that the driving will cost 22 cents per mile for gas and 8.2 cents per mile for maintenance of the car. Additionally, there is a $25 parking fee per week at the college. If Paula carpools, she would pay half of these costs. The cost of the carpool can be modeled by the following equation, where C is the cost of carpooling each week, and M is the total miles driven to school each week. Okay, for part A says explain what each term in the equation represents. Well, if we look at this 0.082, that's the 8.2 cents per mile for maintenance. So if she drives it, so this is going to represent her maintenance cost on the car. And of course, driving costs 22 cents per mile for gas. So this part is how much money she's going to spend on gas. And this is the $25 per week to park. So this is her parking fee. Notice the parking fee doesn't depend on the mileage. But how much gas she uses depends on mileage and how much maintenance her car requires. Now, this 1/2 is because she's splitting the cost with somebody else. Because that's the whole point in carpooling. We'll say splitting a cost with a friend. So that's what each part of that formula represents. Part B says find the total weekly carpooling cost if the commute to school is 7 miles each way and Paula goes to school 3 times a week. So we want to think about this. 7 miles each way. So every time she goes to school, it's 7 miles there, and it's 7 miles back. That's 14 miles. And she's going to do that 3 times a week. So she's going to go 42 miles a week back and forth to school. So her cost is that 0.082 times 14. I'm sorry, times 42. Let me fix that. Whoops. $42 miles plus then that 0.22 times 42 miles plus that $25, and then there's the big. So let's just do this one step at a time. 0.082 times 25. That comes out to be about $2.05. So that's what the estimated maintenance cost is. 0.22 times 42. That's $9.24 for gas. And then, of course, her weekly parking is $25. Now we can just add all that up. 2.05 plus 9.24 plus 25. So it's going to be half of $36.29. It comes out to be 18.145. Well, they're going to have to argue over this half a penny, but it's going to cost roughly $18.15 each week for Paula to go to school. It says a weekly bus pass costs $22. How many total miles must Paula commute to school each week for the carpool cost to equal the bus pass? How many trips to school each week must Paula make for the bus pass to be less expensive? Okay, so they ask actually a couple of different questions. So we already know, if we go back, that if she goes 7 miles to school each way and she makes 3 trips, carpooling is going to be less expensive than that $22 a week bus pass. But that's not the question it says. The first question it says, how many total miles must Paula commute to school each week for the carpool cost to be equal to the bus pass? So if her cost is $22, we end up with 22 equal 1/2. And they want us to figure out how many miles that is. Okay, we want to solve for M right there. We're going to do it step by step by step. Usually you want to combine things that are alike first. So the first thing I'm going to do is take 0.082 M plus 0.22. And if I put these two together, notice they are like terms, they both have M's in them. I'm going to get a new term, I'm going to write it in blue, that is 0.302 M. I added those together. That's the only thing I've changed. Plus 25. All right. There's really 2 ways to do this next part. I'm going to go ahead and just multiply by half to get rid of the parentheses. 1/2 times 0.302 is 0.151 M. So if I do this distributing, that's going to be 0.151 M. If I do 0.5 times 25, or 1/2 times 25, I'll get 12.5. All right. We're still trying to get this M all alone. Our next step is going to be to subtract 12.5 from both sides. 22 minus 12.5 is 9.5. It equals 0.151 M. 12.5 minus 12.5 is 0, so that's gone. We just had to do the same thing to both sides. Now our last step is going to be to divide 0.151. We're dividing by that number because we want to undo the multiplication. They're multiplying by 0.151, so we're going to divide. That makes the right-hand side just M. 9.5 divided by 0.151 is 62.8 miles. I rounded that just a little bit. So if she drives 62.9 miles, it's going to cost exactly the same. If she drives more than 62.9 miles, carpooling is going to be more than $22. That's the break-even spot. So it says, how many trips to school each week must Paula make for the bus pass travel to be less expensive? Well, remember, each trip is 14 miles. So when she went 3 times a week, that was only 42 miles. If she goes 4 times a week, that's still only 56 miles. But if she goes 5 times a week, that's going to be 70 miles. So the answer is 5 trips. If she goes less than 5 trips, it's going to be less expensive. Like if she only went 4 trips and this was 56 miles, if we put 56 in here, real quickly we can figure out what it's going to cost. 0.082 times 56 plus 0.22 times 56 plus 25. We divide that by 2. It comes out to be, if she goes 56 miles, her cost comes out to be $20.96. So it's still just a little bit less at 4 trips. But as soon as she makes 5 trips and she's going 70, if I change this number to 70 now, let's see how much it's going to cost. 0.082 times 70 plus 0.22 times 70 plus 25. When she divides that in half, that's going to cost $23.07. So that's definitely more than the bus pass. It says, recall Widmark's equation for blood alcohol content. In the case of the average male who weighs 190 pounds, you can simplify Widmark's formula to get B equals negative 0.015 T, where T is the time since the first drink, plus 0.022 N, where N is the number of drinks. Forensic scientists often use this equation at the time of an accident to determine how many drinks someone had. In these cases, time T and blood alcohol content B are known from the police report. The crime lab uses this equation to estimate the number of drinks in. Find the number of drinks if the blood alcohol content is 0.09 and the time is 2 hours. So we take our formula. Where's our formula? And we're going to fill in blood alcohol 0.09 equals negative 0.015 times the time is 2 hours, plus 0.022 N. We want to find N. First thing that I would do is go ahead and multiply here. Negative 0.015 times 2. That is negative 0.03 plus 0.022 N. All right, we're trying to get this alone, so we have to do the adding first. We're adding 0.03. 0.09 plus 0.03 is going to be 0.12. Negative plus a positive, of course, that goes away. That's why we did that. Equals 0.022 N. So our last step is going to be to divide by the number in front of N. Whoops. Let's see if we can get back to normal here. I'm not sure what I did. Let's see. Oh, well, let's just Well, it won't let me write, so, uh-oh. Here we are. So we just have to do point, so we end up with 0.12 equals 0.022n. We divide by 0.022, 0.022. So 0.12 divided by 0.022. I'm getting 5.5, and I'm rounding a little bit, is equal to n. So this guy had over 5 drinks. So I would assume they probably would round that up to 6 drinks. Since the lab uses the formula to solve for n over and over, it's easier if the formula is rewritten so that it is solved for n. In other words, n is isolated on one side of the equation and all of the other terms are on the other. Solve for n in terms of t and b. So we're going to take this formula that looks like this. Make sure I copied it right. I believe I did. And we want to get the n by itself. But we don't have definite numbers for b and t. So the first thing we should do when we're trying to get it alone is we want to come in here and we want to move this to the other side. So we're going to add 0.015t. Notice, here's my equal sign. My equal sign is like where my scale is balanced. If I add to this side, I add to this side. And when I do, I get a new, tell you what, I didn't leave myself much room, so I'm going to erase and start over. I just really want you to see how this works. So here's our equation. B equals negative 0.015t plus 0.022n. You can think of the equal side as being like a scale that's balanced. We had a platform scale here. This side exactly balances this side. Those two things are equal. They may not look the same. B, you could think of B could be like $100 bill. And this should be some pennies and some $1 bills and some all kinds of gobbledygook. But as long as it adds up to a $100 bill, we're equal. So that's what an equation tells us. Both sides are equal. Well, if both sides are equal, when you solve it, you can think of this as being, put in a little imaginary line here. I just have to keep both sides equal. So if I do something to one side, if I add something over here, so I'm going to add 0.015t, then I have to add the same amount over here. So I'm going to add 0.015t. After I add that to both sides, I get this new equation. My new equation looks like this. B, whoops, I changed color, I didn't even mean to, plus 0.015t is exactly equal to, well, now remember, if you added this is going to go away, 0.022n. All right, still trying to get n by itself. So I need to, since it's being multiplied, I'm going to have to divide by 0.022. So I have to divide all of this by by 0.022. And when I'm done, I'm going to get this new formula that says n, this side is n, is equal to b plus 0.015t over 0.022. This is the formula. I'll probably turn it around because I'll probably write it like this. N equals B plus 0.015T divided by 0.022. And that way we just have to plug in B and T each time and we're good to go. It says use the new formula to find the number of drinks if the blood alcohol is 0.17 and the time is 1.5. So I got N equals B plus 0.015T over 0.022. Let's double check. That's our new formula. So we plug in the information. I'm going to plug it in a different color. B was 0.17. So plus 0.015 and then T, plug T in a different color also. T is 1.5 hours. And all of that's divided by 0.022. So that's going to be 0.17 plus 0.015 times 1.5 is 0.0225 over 0.022. We just keep simplifying. The top is 0.17 plus 0.0225. That's 0.1925 divided by 0.022. And that gives me 8.75. Notice this person had a very high blood alcohol content when he had not been drinking that long a time. So 8.75. Here's some more practice. It says solve A plus 2B equal 12 for B. So think about this as your little imaginary scale and you're trying to get this B alone. The first thing you do is take the A away. When you take the A away, this side is just 2B. But this side becomes 12 minus A. Now we have to finish solving by B, so we have to divide by 2. So we divide by 2, and we get B equals 12 minus A divided by 2. So that would be our answer. And now it says solve this one for X. Now this one's a bit harder. There are a couple of approaches you can use for one that looks like this. One of the things I think that helps students a lot is to write it more like a proportion. Say y over 1 equals negative 2 over 3x minus 1. We are going to cross multiply. I think this is, I have mixed feelings about how to do this one. So when we cross multiply, we're going to get negative 2 equals y times 3x minus 1, which gives me negative 2 equals, I have to distribute 3xy minus y. Okay, you may not think that looks much better, but let's keep going. We're trying to solve, and it's really important that you remember we're trying to get the x by itself. Think of this as that imaginary scale. Add y to both sides. And this side becomes negative 2 plus y or y minus 2. It doesn't matter whether you write negative 2 plus y or whether you write y minus 2 equals 3xy. Notice those go away. Okay, so this is not so bad. We're trying to get x by itself. Look what's going on with x. It's being multiplied by 3 and it's being multiplied by y. So we need to divide by 3y. When we do that, this side is just plain old x now. 3xy divided by 3 and divided by y is just x. This is y minus 2 over 3y. So we get x equals y minus 2 over 3y. That one was definitely harder. Like I say, since this side is a fraction and this side is not a fraction, you can put the side that's not a fraction over 1, and then it looks more like a proportion, and you can cross multiply it to get it where you don't have a denominator. It's having that denominator that causes the problem. All right, I think this is our last one. We want to solve b over d minus a equals c for b. So we're going to start with b over d minus a equals c, and I'm going to put it over 1. I can make this side look like a fraction. This one works out really easily because look what happens. When I cross multiply, b times 1 is just b. This side is going to be d minus a times c. I do have to distribute there. I could leave it like that, or I can say, look, it's c times d minus c times a. It takes practice, but that finishes up this for this video. That gives us everything from the lessons for chapter for lesson 15, A, B, and C.